Hi, I'm Shannon Seaver, and today we're looking at logarithmic functions. This is part 2, and specifically today we're looking at how to convert logarithms from one base to another and solving equations with logarithms. So first of all, there is something that you need to know, and it is the change of base formula. So here we have a, b, and x, and we're going to let them all be positive real numbers, and a cannot be 1 and b cannot be 1. So the log of a, x, can be converted to another base. So here we have log a of x, and we can change that to log base b by taking log b of x divided by log b of a. If we wanted to convert it to base 10, we would take log of x over log of a, and base e, the natural log of x over log of a. So this is something you probably should write down in your notes and memorize for the exam. Let's do some examples. So here we have log 4, and we want to switch to log base 10. So what we're going to do is we're going to take the log of 25, and we're going to divide that by the log of 4. Now that we have it set up like this, we can actually use our calculator to solve what log base 4 of 25 is. And once you put this into your calculator, you're going to get the answer of 2.32. So I'm going to pause the video. I'm going to let you try log base 2 of 12, and then start the video again and see if you got the right answer. So here I have the answer of 3.58. Okay, so the next point of logarithms is really to help you solve exponential problems without having to guess and check. So basically, the way we're going to do this is we're going to take the log of both sides of this particular equation. So it would be log 4 of x to the minus 2 equals log of 64. And if you used your logarithm properties, you know that you can take the exponent and put it in front of the log. So this will be x minus 2, and I'm going to put parentheses around that, make sure that I remember that's all together. Log 4 equals log 64. Now, if I put log 64 into my calculator, I get 1.806. And if I put log 4 into my calculator, I get 0.602. Now I want to solve for x. So what I'm going to do here is I'm going to divide both sides by 0.602 and just go ahead and get rid of that. And I get a total of 3 right here, and then x minus 2. So I'm going to solve for x. Now I'm going to add 2 to both sides, so x is going to be 5. And that's our answer on that one. We can go back and check to make sure by putting it back in. So it'll be 4 to the 5 minus 2 equals 64. And then 4 to the 3 equals 64, and that is true. So that's what we would do to solve these real quickly, is to use logs. Pause the video, try the second one here on the right, and then check back in to see if you did it right. So we got a total of x of equaling 2.81. One last example. Here we have logarithms, and we want to actually go back and solve this using exponents. So what we're going to do is, I already have this written out. We're going to walk through it. So remember, when we have a plus sign, we're going to actually, we can contract this and make it a multiply. So it would be x times x minus 3 equals 1. If I take this to the power of a base 10 on both sides, what happens is the 10 log base 10 disappears. So those kind of cancel out. So then I have x times x minus 3 equals 10. Then, after I multiply it out, I can bring 10 to the other side of the equation. So I have x squared minus 3x minus 10 equals 0. And then you can factor these out, or you can use the quadratic formula as well. So we have an answer here of 5 or -2. That's the end of this video. If you have any questions, please bring them to class.